friends, welcome to Moral's Math Corner. Today we are going to work on graphing all trigonometric functions. I'm not just going to teach you the easy way. I'm going to teach you everything complex, all the way, everything that we need, okay? Because it's going to be a lot easier and better for you in the long run. We have so far just visited graphs that look like this, okay? In that particular case, the A was the amplitude, the B helped determine what the period was. Well, now I'm adding two things. I'm adding a negative D inside of the parentheses, okay, directly manipulating the X or the angle measure. And I'm also adding a C on the outside, okay? The inside D is going to shift your trigonometric function left or right. If it's negative D, you're going to go to the right. If it's positive D, you're going to go to the left. The C is going to shift your baseline up or down. Positive C, you're shifting your baseline up. Negative C, you're shifting your baseline down. Now, the way the book wants you to do it, and most teachers do this, is that they first graph the parent function. The parent function, which would be this guy right here. Once they graph that, then they take each point and they shift it to the right or to the left based on the D, and then they shift the points up or down based on the C. I'm not knocking that method. That method works. It is valid, and I will not teach it to you. It is not what I like to do. It is not efficient at all. I think it's a little bit of a waste of time. The way I have formulated this, I promise you, all the shifts will be included. I promise. So just have faith in me. Learn what I'm going to teach you, and you're going to be golden. So I'm going to get rid of all of this. All of this is valid, though. I want you to understand what's going on. When you see something being, again, subtracted from the X, you're going to the right. You know. Because they may give you a question on the ACT. They may say, describe the translation. This translation is you're going right 90 and you're going up 6. The way we graph it, we're not going to do it that Mickey Mouse way. We're going to do it a much better way where we have the perfect graph already shifted. But if they just simply ask you, describe the translations here, that's why I teach you what's going on. This guy, the negative 90, that means I'm shifting to the right 180. This 6 on the outside, that means I'm shifting up 6. Does that make sense? Okay, now. Let me get rid of all of this and do what I wanted to do. Okay, my A is the amplitude, the absolute value to be exact. Okay, you don't even really have to write this down because you have this already in your notes. Now you, my friend, do not have this. You are absent, so you definitely have to write it down. But remember, I am filming it as well. Now, before, we used to take the period. We used to find the period by going 360 divided by B. We're going to change that up completely now. Now we're not looking only at the B, but we're looking at everything that affects this X. So the B times X minus D equals the determining of the period. One complete cycle. And how you find that is very simple. The period is going to equal B times X minus D has to be set greater than equal to 0 or less than equal to 360 or 2 pi. Once you set this up, okay, this is going to be your starting point, and this will be your end point. Once you have your starting point and your end point, plug it into your period formula, just like we did with the tangent. See, I've unified everything. That's the beauty of my method. It's the same for every single type of graph. Your endpoint minus your starting point, that's your period. Divide your period by 4 to find your interval. And of course, you know by now, hopefully, that the sine graph follows the following pattern. Base, peak, base, trough, base. So the only new thing that you should add to your note cards or your notes in general is this right here. That's the new perfect way to find the period, no matter how complicated it is. Mr. Morrow, but what if they don't give you a D? Great, then you don't have to worry about it. It's 0. Easy. Yes, sir. Oh, I thought you had a question. I'm sorry. Yes, sir. So anyways, now the C changes the baseline. Okay? The baseline. When you have a C other than 0, you're going to move your baseline up or down. And I'll show you exactly how to do that. I'll show you exactly how to do that. But you got to know that the C is going to shift your baseline. If C equals 0, then the baseline is the x-axis. So just so you can kind of get a little picture, let's just say I had the sine of x plus 4. Okay? My baseline normally is my x-axis, correct? Now let's say, actually, just so you can really see it, say 2 sine of x plus 4. But I have this plus 4. It's not in parentheses, so that means I'm moving it up or down. If it's positive, I go up. If it's negative, I go down. So I'm moving the whole entire function 4 units up. So my new baseline is going to be here at 4. My new baseline here is at 4. Now, my amplitude is 2. So the height that I will go to now is 6. That's my peak. And my trough would be 2. Because remember what I told you about the amplitude from the beginning. From the beginning I told you this. The amplitude is how high or how low it goes from the baseline. In this particular case, the baseline is 4. So from the baseline, I go up to and down to. Does that make sense? No, because I have a video. So I cannot scroll up. I'm sorry. Now, if I have the negative sine graph, this is the way it's going to look, guys. And I want to explain something to you. On the quiz yesterday, when I asked you for 2 periods, most people got this side right. But then they went like this. Don't laugh. It's not funny. It's a mistake. It's a valid mistake. So let me show you how to avoid that mistake in the future, please. First of all, we know that this is one full complete cycle. This is one full period. So let's find a period to the left of it. So I'm going to go negative 90, negative 180, negative 270, of course in radians, and negative 2 pi. Don't we read graphs from left to right? Okay, this is a negative sign, right? Base, trough. Base, peak, base. This way, you never get the wrong flow. When you're setting up your new period and you have your new intervals, just follow the same pattern from left to right. Does that make sense? Promise. Okay? Awesome. Cosine, same identical thing to sine. There's nothing new, nothing different, except how the sine graph is, how the cosine graph is actually formed. The cosine graph goes peak base, trough, base, peak. Okay? It's the only difference, my friends. It's the only difference. The C is still going to move it up or down. The interval is still going to be the period divided by 4. How you find the period is still going to be b times x minus d is greater than or equal to 0, but less than or equal to 2 pi, or 360. You get the end point minus the starting point. That's your whole period. You divide it by 4. You find your intervals. Same thing. So the cosine and the sine are identical as far as calculations go. As far as the actual graphing goes, of course, it's a little bit different. Now, I don't know if you guys have noticed this yet or not, but remember how I said that sines and cosines are cofunctions when we first started trig? They're off by 90, right? You notice this, guys, just for giggles. You notice that if I shift this peak of the cosine 90, I'd be here. And wouldn't that then be the sine graph? Pretty cool, huh? That's the only thing between the sine and the cosine, and also between the tangent and the cotangent. They're off by 90 degrees. So it's very difficult sometimes to determine, oh my God, what is this? Is this a sine graph or a cosine? I would know it's a cosine graph because I went from a peak to my other peak. The sine segment of this would be from base to base. Does that make sense? Okay? Not really anything to do with actual graphing, but I'm just trying to make some connections here. Now, if I have the negative cosine, my friends, it's right here. Okay? Now, let me erase this and show you what I did, because I want to show you how to do another interval of this as well. Okay? Please remember that when it's negative, I'm going trough, base, peak, base, trough, from left to right. So, say I want to do another period. This is one full period already, right? You with me, guys? So I have to have, so there's 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. Let's say that I had already the period. I'm not going to do the math for this right now. But let's say we had the period. We had all the units. Actually, it should be pretty easy. It's every 1.5. So that'd be 4.5, et cetera, et cetera, et cetera. From left to right, don't we go trough, base, peak, base, trough. Actually, that should be there. And you'd have your cosine graph. So when you're doing your next period, whether it's to the right of it or to the left of it, set up your period, set up your intervals, and then just follow the pattern from left to right. It's got to flow. See how it flows? You cannot have it like this, where this is going this way, and then now this one is going this way, like that. You can't do that. Okay? It's got to have the same pattern. Does that make sense, everybody? Yes, no, maybe kind of, sort of? Okay, good. That means I'm going to have plenty of time. Tangent. You can kind of relax for this one because I already taught you this. There's nothing new. The only thing new today for the tangent is the C. I can shift the baseline up or down. The amplitude, there is no real amplitude here for the tangent. It doesn't really exist. The amplitude is more of a guide point. You find your asymptotes by setting looky, b times x minus d equal to negative pi over 2, negative 90, or positive 90. If you notice, this is constant every single time. For sine and cosine, you set it to 0 and 360. For the tangent, you set it to negative 90 and 90. This is your starting point. That's your end point. Your period is end point minus starting point. You get your interval by dividing the period by 4. Positive tangent graph. Left to right increasing. Left to right increasing. Left to right increasing. And these are all my asymptotes. You had a question, sir?
The only difference between this.
No, everything is the same with the tangent notes. I had the starting point and the end point with the tangent. I don't like teaching tangent the other way. I included C and D, but we just never had any C and D values. But all the formulas are the same, sir, I promise you. No, thank you, sir. Now, my negative tangent. I colorized it a little bit because they were really light. Negative tangent, I'm going down from left to right. Down from left to right. Down from left to right. Okay? Does that make sense, everybody? I'm not going to try to jam down your throats cotangent in 3 minutes. So let's just go ahead and ask anything, any little nitpicky thing you want to ask now. When we get back, show you cotangent, cosecant, and secant are ridiculously easy. And then we'll do a few examples. But most of the work is going to be done by you guys tonight. So I need you to really make sure you understand the steps here. If you don't, please let me know and I'll be happy to help you out. Okay, we'll be back in a flash. All right, so we now know how to do our sine and our cosine and our tangent. Should be very simple. Follow the procedures. Now, the cotangent. I'll put this up here in a second. I'll show you this in a second. Okay. So, the cotangent. Cotangent is the reverse of the tangent as far as the shape goes. Positive cotangent is going to go in the same direction as a negative tangent would go. So, a positive cotangent goes down from left to right. A negative cotangent would be the same as a negative tangent. It would go up from left to right. So they are reversed. A positive cotangent, okay, in blue, is like a negative tangent. Negative cotangent in red is like a positive tangent. It's reversed. Okay? Everything else is the same as far as the asymptote. You're going to use guide points. Now, the only difference here is this bad boy. For your actual asymptotes, for the tangent, you set it between negative 90 and 90. But aren't the tangent and the cotangent co-functions? They're reciprocals as well, but they're co-functions as well, right? So don't they shift by 90? So if the tangent's parameters, its periods were between negative 90 and 90, shift 90 to the left, what do you get? 0 and 180. What's negative 90 plus 90? 0. What's 90 plus 90? 180. So that's the only difference between the tangent and the cotangent, and of course the way they're shaped. Everything else is the same. Once you find your endpoint minus starting point gives you your period divided by 4, that gives you your interval. Okay? So far, everything is the same. You just got to know the parameters. Sine and cosine, you are going to be setting the b times x minus d. You're going to set that sucker between 0 and 360 always. That's it. Done. From there you get your period, from there you get your intervals, but that's the big important part because it determines your starting point and your end point. Now, for the tangent, you're setting the same b times x minus d equal to negative 90, or negative pi over 2, of course, and 90. And the cotangent, you're setting the b times x minus d. You're setting that equal to 0 and 180. So it's not really much to memorize, really. That's why I like doing it this way, my way. It's consistent for every single graph. Consistent. It's the same thing. Now, I know people are writing, so I'll split the screen so you can see it all. The negative cotangent, just I wanted to show you. Okay? Positive cotangent is in blue again. That's going down from left to right. So the positive cotangent acts like a negative tangent. The negative cotangent in red goes from left to right up like a positive tangent. They're reversed. You had a question, sir? The question is, why are the parameters for the cosine and sine less than or equal to, but not equal to? Okay. We set the parameters of the tangent and the cotangent equal to because at that spot that it's equal to, my end point and my start point, those are asymptotes. They stop. You cannot go on. But for a sine or tangent, my starting point, that is a real point, isn't it? That's why it could be greater than or equal to that point. The sine goes from here, greater than or equal to this point. And when you're going from the right to left, it's less than or equal to that point. Correct. It's not stopped. It continues forever. There is no asymptote. Remember that the sine graph will continue like this forever. There is no stopping point. Thank you. Good question, son. Okay. So does that make sense? Yes, sir. No, I don't make them less than or greater than. Also, I set them equal to so that you know that those equal the asymptotes. You cannot go beyond those. Those equal the boundaries. That's it. You're done right there. Thank you, sir. May I continue, my brothers? Good questions. Okay, now, I've got the cosecant and the secant. Let me erase all of this, first of all, to make your life a little bit easier. Okay, my friends, if you notice here, you may say, uh-oh, Mr. Morrow got lazy. There are no formulas here. There's nothing. He probably just didn't do it. He'll do it now. No, there's nothing to do. When I have a cosecant, what function is reciprocal to cosecant? Guys, look at this. Isn't this a sine graph? So what you do when you see cosecant is you graph the sine graph, right? So you would, in this particular case, this is a negative sine graph, right? This one's negative because I'm going base, trough, right? Base, peak, base, right? So that's a negative, right? You draw the normal sine. You with me? Now, at all the zeros, you draw an asymptote. All the zeros, you draw an asymptote. And of course, these are the zeros, the x-intercepts. Those are the x-intercepts, right? Now, you make a parabola at every peak and trough in between the asymptotes. So, you go like this, boom, boom, and you're done. And of course, you could have hundreds of these, depending on how many periods you have. But for our intents and purposes, all I'm going to want is just one period, one set. I need 2 parabolas for cosecants and 3 for secants. We'll talk about secants in a second. Now, if it was negative, I'm going to do it in red. I'm sorry, stupid. If it was positive, I'm going to do it in red. It'd be base, peak, base, trough, base. Same thing. My asymptotes at the zeros, and at every peak and trough, a parabola between the asymptotes. Yes, question. Yes. Yes. For a cosecant. Yes. Yes. No, you do not have to erase the old lines of the sine. Just don't make it super dark. Make it light. Yes.
If it's a negative sign, is it?
If it's negative cosecant, then you graph the negative sine graph. If it's, guys, do I talk in code? I said in blue. This is a negative cosecant. So you graph the negative sine. You have asymptotes at the zeros and a parabola at every peak and trough between those zeros. If it's a positive sine, a cosecant, then you graph the positive sine graph. Asymptotes are at the zeros, and you make a parabola between the asymptotes at every peak and trough. For the secant, it's identical to the cosecant, except the secant has a reciprocal function that's called the cosine. So, in this particular case, this is a positive cosine that I'm going to base this positive secant on. So, peak, base, trough, base, peak. That's my positive cosine, right? Okay? Then I have an asymptote at all the zeros. So an asymptote here and an asymptote here. Now, you can see you only have 1/2 of this graph. You only have half of it. That's okay. All you got to do is make a parabola at every peak and trough. So, for secant, I'm going to need 3 parabolas. Okay? I'm going to need 3 parabolas. 2 for the secant, 2 for the cosecant, 3 for the secant. So write that down, and then let's do some examples, and then you can ask some real questions based on some real examples. And thank you. Bless you, son. Okay, you ready? Let's do a couple right now. Okay. Now, let's do some examples. Okay, before we do examples, though, let me show you right quick. I just did this just to give you a bird's eye view of everything. All right? I have my positive sign is in black. I'm going to do negative sign in red. Positive cosine in black, negative cosine in red. Yes? No, okay, the question was, isn't this cosine graph? No, that's why I called it sine. It's just not 2 full periods. This positive sign goes from here to here. So like I said, the negative sign would go from here to here in 1 full period. Sir. Okay? Okay, you thought wrong, and that's okay. Now, the cosine would go from here to here. The negative cosine from here to there. This would be my positive tangent going up from left to right. My negative tangent would go down from left to right. My this is my cotangent. My cotangent, as you can see, is going down from left to right. The negative one would go up from left to right. Please notice that they're the reverse of the tangent. The secant graph, okay, is based on the cosine graph. So the cosine was like this, and that's my secant. Okay? And then my cosecant is based on a sine graph. And that would be my cosecant. Okay, so just a little bird's eye view. Now, let's get to this. All right. Let's go ahead and graph y equals the cosecant of 1/2 x minus pi over 4. I suggest working in degrees first, and then if you want to put radians, do that after, okay? It's a cosecant, so we're going to model this after a sine graph. So I am going to pretend that this is a sine graph. My amplitude is 1. I had no shift in baseline, so my baseline is the x-axis. Now, step 2, I want to find the parameters of my period. So 1/2 x minus 45 degrees equals 360, but also equals 0. I'm going to add 45 to both sides. So I'm going to have 45 equals 1/2 x, which equals 405, times 2 to all three sides. You get 90 degrees equals x, and equals 810. So I know that between 90 degrees, my starting point, and 810, actually this makes it a little bit longer, and 810, that's one full period. So now my period distance is 810 minus my starting point of 90, so that's 720. My intervals are the period divided by 4, which is going to be 135 degrees, I think. No, 180. My bad. 180. So, my starting point is where? At the 90. And you know why? Remember how I said when this is negative, you go to the right? It's negative. Am I not going to the right? Okay. So my starting point is 90. I have a cosecant, which is based on sine. So I graph the sine. Well, first let's do our interval. Sorry. 180, 270, plus 180, 450, plus 180, 630. Right? Plus 1. Okay. So there you go. So now I have base, peak, base, trough, base. I'm going to lightly graph it. Now, my asymptotes are at the zeros. And then a parabola at every peak between the asymptote and at every trough between the asymptotes. Now, let's be honest. It's not too hard, is it? If you know how to do your sine and cosine graph, you're golden. Yes, sir. Why did I do it lightly? Because the real graph are the parabolas. That's the cosine and secant. I mean, that's the cosine graph. The little lightly stuff was just so that I can make my life easier to guide us as to where to put those parabolas. That sine graph is not part of the cosine. That's why it's dashed. That's why it's a light line. It's a guide. Yes, sir.
You want 2 periods of the cosine?
Okay, I had already answered that, but I'll answer it again. When I have a cosecant, all I want is 2 parabolas. When I want secant, I want 3. Okay? Does that make sense? Hello? Okay, let's do another one. Okay, this was, I'm sorry, I had graphed this from before. This is the same graph, but a little bit bigger. Okay, but I already graphed that, so we don't have to worry about that. Let me just go ahead and actually, I'll just skip it. Okay, now let's get to a good one. Okay, now, okay, this is a sine graph, straight up sine graph, right? But this is being added. Actually, you know what? This is kind of messy. Let's do this again. Negative 3 plus 2 sine of x plus pi over 2. Okay. Now, thank you. Someone said that the negative 3 is the c. Yes, sir. So that's the first thing you're going to do. My baseline is originally x. But now I'm shifting this negative 3, right? So go down negative 1, negative 3. Make a nice predominant line. That's your new baseline. What's my amplitude? 2. So from the baseline, you're going to go up 2, that's going to be your peak. Down 2, that's going to be where your trough is at. You feel me? The amplitude goes up or down from the baseline. Next, period parameters. You got x plus 90 equals 0 and 360. So x is going to equal negative 90 degrees and, oh boy, 270. Now, let's find the actual period. The period is 270 minus a negative 90. Because remember, it's end point minus starting point. So that's going to be 360 degrees. My intervals are 360 divided by 4. So that equals 90. You with me, guys? So now, my starting point here was at negative 90, right? Negative 90. My ending point was at 270. Do I have to put asymptotes for a sine or cosine? No. That's just my starting point and my ending point. I'm talking about a positive, right? Okay, so I'm going to go base, then peak. My intervals are 90. So negative 90 plus 90, I have a point here at 0. Plus 90, plus 90, plus 90, you get to my 270. Base, peak, base, trough, base. You're good to go. Now, for Mr. Mole, you said you wanted more than one period. Okay, cool. No worries. You can either go to the left or to the right, okay? My period is 360 degrees, right? So what's negative 90 minus 360? Negative 450. Right? So that's going to be the starting point now from here. So negative 450 plus 90 is negative 360. You with me, guys? Plus 90, negative 270. Plus 90, negative 180. Plus 90, bam. Now remember, start the same way from left to right. Base, peak, base, trough, base. It should link right up. Does that make sense, my brothers? Okay. Now I only got 2 minutes left. Just bear with me on this one. Okay? Cotangent. Let me show you what I did here. The work is all here, but I promise I'll explain it right now. First off, asymptote. You set the x that they gave you equal to 0 or pi, which is, of course, 0, 180. Okay? So, look what I did. I made an asymptote here at 0 and an asymptote here at 180. I have a negative 2 here that was being added to the cotangent. So if you notice, I went from my x down negative 2 because that's my new baseline. My period is 180. My intervals are 180 divided by 4, so my intervals are 45. So for my asymptote of 0, plus 45, plus 45, plus 45. I'm dealing with a negative cotangent. Negative cotangent acts like a positive tangent, goes up from left to right. So, my first interval, guide point. Second interval, baseline. Third interval, guide point, blammo. Done. Does that make sense, gentlemen? You got a question?
Why aren't the graphs like, why are they curved? Why aren't they, straight lines?
Why aren't these graphs curved? Why are they curved? Why are they not straight lines? Because we're in a circle.
Oh.
Thank you. That graph does not really look like that. That's a two-dimensional view of it. That graph is really circular. It's really a circular motion. That's why it's curved. Great question, son. Thank you. Does that make sense, guys? So you got this on lockdown, right? All right. God bless you all. Have a great day. Hasta la vista. Goodbye.
How would you say 4 dimensional?